Hi, it's Dorian. Really sorry I can't be with you guys today, but I'd like to share one of my favourite fuse and earthwire demonstrations with you, informally known as Dangerous Kettle Man. This is the metal body of a kettle just here, made from coat hanger wire. We've got a nichrome heating element. This is just some nichrome wire wrapped around a wooden splint, and it's powered by a standard bench power supply which is set to 7 volts DC. Our current flows in through this red wire, through a thin piece of fuse wire, that's just a single strand from a bit of copper multi-core wire, and then the current flows through this brown wire in our 3-core flex, through the heating element, and then back to the power supply via this blue wire. You'll notice that it runs through an ammeter, and we've got Einstein here monitoring the current for us, which is around about 0.6 amps at the moment, just short of 0.6 amps. Now you'll also notice that under normal circumstances we have got our heating element warming up quite nicely. In fact, that is at about 102 degrees at the moment. You can actually feel the heat kind of being radiated off of this quite nicely. So, as you know, there's an earth wire which connects the metal case of our appliance here down to the ground. And under normal circumstances, we don't need this. So we can in fact disconnect this altogether. Our current stays the same, and our heating element is still very nice and warm at about 100 degrees, give or take. So, let's have a look at what happens when one of the most common faults occurs. So one of the most common faults to occur with an appliance like this is that the heating element comes into contact with the metal case. Now, if this happens, well, a couple of things change. For one thing, the current's increased to just short of 0.7 amps. But that's not sufficient to melt the fuse. So we've now got current running through the metal case of the appliance down to ground through our person. And in this case it's making a bulb light up in the middle, but of course in reality you'd be getting a fairly nasty electric shock at this point. So this is of course where the earth wire comes in. So we said the earth wire connects from the metal case to the ground. And as you know, it's a very, very low resistance path. So if we have the same fault occur, we should find that basically the current will increase a lot more, and that should be sufficient to melt the fuse. So let's have a quick look. So the same fault occurring now, we're just going to keep an eye on the ammeter here and this piece of fuse wire. And there, we saw that the current shot up massively this time. The fuse glowed very brightly with this increased current and the heating effect resulting from that, which caused it to melt and break the circuit, rendering our user safe. So, there you go, that is Dangerous Kettle Man. You can make your own if you look for the instructions on the Institute of Physics website. Thanks very much, bye bye.